Hello my dear students. Today we are moving on to the fourth module, knowledge representation by using logic. In the third module we actually cover two parts. The first part covers game theory and the second part we discuss actually the different types of knowledge representations. That means knowledge can be represented in different ways. For example, knowledge can be represented in the form of rules. And that knowledge representation technique is called production systems that we have already discussed in module 1. We can represent knowledge in the form of some pictorial representations like frames, like charts, like graphs. We can represent knowledge in the form of some logical, true or false statements, logical statements. We can use different techniques. So the part 2 of third module actually covers the introduction to different knowledge representation techniques, and in the fourth module we in detail discuss the logical knowledge representation, how knowledge representation is done by using logic. That is in detail described in the fourth module, how that is being represented, how that is being made to the machines to learn, how that the machines are responded to that, and how easy or how difficult is it for the machines to learn the knowledge representation using logic. And different aspects of logical knowledge representations are being discussed in the fourth module. So we all know that humans are best in understanding. We are very good in reasoning. We are very good in interpreting knowledge. So we know things, we have knowledge in our hands, and we are actually communicating that knowledge in different ways. If somebody is there and we want to represent our knowledge that we have, we use actions, we use languages. So we use different methods for representing the knowledge. So one of the most common method of representing knowledge is natural languages, and even in the natural languages we are using different tones, we are using different verbs, we are using different connectors for conveying our messages. Sometimes when we taunt somebody, when we tease somebody, they tell that don't talk using inner meanings. That means we are talking in a natural language, we are talking a normal sentence, but that particular person is getting another meaning. That means that particular person is actually able to connect with what we are talking about. So we are encrypting some inner informations in a normal language. So that is the capability of a human being, and it is very difficult to make machines do this. So that's a main problem that we are facing here. So how machines do all these things comes under the knowledge representation and reasoning category. Okay, so in artificial intelligence, when we talk about the knowledge representation, there are different kinds of knowledge involved in that. The first type of knowledge is object. That means a real life entity, as we talk about some nouns in the terms of grammar. So that is object. It's a real life entity which has its own existence. And what is event? Event means an action. This is also a kind of knowledge that we should have. This is a bit of theory now, but when we are discussing the examples of how to represent our knowledge, it will be super easy for you to understand. Okay. Now the next type of knowledge is the kind of knowledge that involved in logical representation is the performance. That means it's actually describing the behavior of the object or an event. So it's actually the performance. Then another knowledge type involved here is the meta knowledge. We are much familiar with this term, meta. That means about. Meta knowledge means the knowledge about something. Sometimes it may be the knowledge about an object, knowledge about an event, knowledge about a performance, whatever it is. Meta knowledge is very important. And the next concept is facts. Facts are something which is predefined. That means it will be already solved by somebody or some experts or somebody in the past, and we are using that particular knowledge or that particular fact without any further procedures. We are accepting it because it is already proven fact. So that facts are being used in solving our problems. So it is also a type of knowledge involved. Facts, they are the truths about the real world, and what we represent, it is already being proved by somebody else in the past. And the next is the knowledge base. It is a central component of knowledge based system. The knowledge base is actually a type of database here, which works as a combination of knowledge or the group of sentences that we already have. So from the knowledge base we are getting, and we are adding to the knowledge base, we are getting data from the knowledge base. So it is actually working as a database. In a database management system, what is the use of a database? We all know that. So likewise, in a knowledge representation system, knowledge base act as a storage. Okay. Now some other information about knowledge is different types of knowledge: declarative knowledge, heuristic knowledge, meta knowledge, procedure knowledge, and structural knowledge. There are actually 5 different types of knowledge. The first one is declarative knowledge. It actually shows some declarative sentences, facts. Sun rises in the east, sun sets in the west. They are already proven facts. So we do not go in detail what happens inside it. We do not go in research with that, because we already what we say, accept that fact. So that type of sentences or that type of knowledge is called declarative knowledge. Heuristic means it is a rule of thumb. That means already defined rules that may be defined by some experts. Meta knowledge is the knowledge about something, and the procedure knowledge is a type of knowledge which helps us, or which tells us how to represent something or how to do something. The procedure actually from the term itself. Structural knowledge shows the relationship between some objects, some events. It shows the relationship. So we'll see it in detail. Declarative knowledge means we know about something, and it includes the concept, fact, object. So declarative sentences is the example for that. And in the procedure knowledge, as I have already told you, it's like imperative knowledge. The procedure knowledge is the type of knowledge which is responsible for knowing how to do something. That is very important. Okay. And we have already discussed about meta knowledge is a knowledge about some other different types of things. It may be different types of knowledge. It may be different types of objects. So any knowledge about any other things is called a meta knowledge. Heuristic knowledge is actually representing the knowledge of some experts. That means that will be already proved or already filed, and we are taking it as a reference. So some reference knowledge is called heuristic knowledge. And at last, structural knowledge. It shows the relationship. When we are into a problem solving concept, it shows the relationship, like a kind of, a part of, some relationship is there. So that relationship is shown by using structural knowledge. These all are some different introduction or theoretical aspects. We are now actually not in the concept till now. So we are describing it. We are just giving a brief intro, so that it will be easy for you when we are discussing the concepts. Okay, core concepts. So for a decision maker in a system, in an intelligent system, there is knowledge, there is some actions, there is sensing. So these 3 components are working together. So these all are theoretical aspects. Okay. Now what happens in an artificial intelligence knowledge cycle? What happens there? We have 5 different points there. Perception is, that means we are conceiving something through our senses, maybe through our vision, maybe through our sound, maybe likewise. So sound and vision is the most important perceptions, and touch is there. So different perceptions are there, and that helps us to receive something. So we are receiving the data, and we are making the machines to learn that. So perception is there, learning is there. So this is the area of capturing the knowledge. Knowledge can be captured by using different scenarios. It can be by using vision, it can be by using sound, it can be by using touch. So whatever it is, we are perception actually means the capturing of knowledge, and after capturing the knowledge, we are making the machines learn things. So we are that is actually machine learning. Now once learned, we are now going to represent that data, represent that knowledge. Then from that representation we will plan it, then we will execute it. So this diagram clearly shows how to represent the knowledge cycle here. And the first point here is perception, and from perception we will learn something, and directly move to the representation concept. Knowledge representation is happening. Knowledge representation can be using different methods. It can be by using rules, it can be by using logic, whatever it is. From this knowledge representation, we are taking some inference and we are doing some reasonings. According to that reasoning, we are planning what to do next and we are executing that plan. The education term is used besides execution, so you can use execution there. Okay, education or execution there. So this is a complete diagram, shows the knowledge representation cycle. Now moving on to this next theory point, that is what are the qualities of a good knowledge representation system? The first quality is representational accuracy. That means a good knowledge representation system should be able to represent all type of data and that be in a real format. That should be reliable. Okay, so the representation should be in an accurate format. Whatever the data is, whatever kind of data is being represented, it should be accurate. And the next quality of a good knowledge representation system is inferential adequacy. That means the method of converting the already existing data, the already existing knowledge, the already represented knowledge into a new idea. That inference is to be done and that is to be adequate. And the next point is inferential efficiency. Your representation of knowledge, your inference from that knowledge should be efficient and that should be able to file somewhere or should be used in the future. And the last point is the acquisitional efficiency. That means if your knowledge representation system is very good or of high quality, that should be able to acquire new knowledge easily, automatically. Okay, so suppose we already discussed one type of knowledge representation, that is by using rules or the production system. So when we are using the production system, that production system should have to what we say, it should contain all the information regarding the problem. It should contain all the rules which satisfy the scope of the problem. That means it should be complete. Then only we can solve that problem in an efficient way. Now to the point, techniques of knowledge representation. There are different techniques of knowledge representation. These are the points that is been covering in third module: logical representation, semantic representation, frame representation, production rules representation. Now we are going to discuss the logical representation in detail. So this is the same. Okay, these 4 points are being shown in a diagram. That's it. So logical representation, this is the point that we are to. Okay, so logical representation means we are representing the data, we are representing the knowledge in the form of logic. What is logic? It is a special language for a system which helps us to convey the knowledge that we have in the form of whatever it is, in the form of symbols, in the form of some connectors, in the form of some objects, in the form of some events. We are communicating what we have as a knowledge to the system, and we are making the system learn how to communicate that knowledge that they acquire. So the knowledge representation category has the same structure of a normal natural language. It has syntax, it has semantics. So when we consider the English language, it has a syntax. When we are using a sentence, it should be in a proper syntax. That means it should have a noun, and if there is a noun, that should come first, and then the verb should come, the adverbs will be there, the adjectives will be there. So that is to be used in particular areas or particular positions in a sentence, so that the sentence will come up meaningful. So mouse ate the what we say, cheese. Mouse ate the cheese. So if that particular words in the sentence are getting misplaced, ate the mouse cheese, will it communicate? No. So likewise, in a natural language, we are using many different syntax and semantics. The same is coming up in the case of logical representation. there will be a syntax. Syntax means it should have a structure for constructing the legal sentences, logical sentences. So a normal natural language, it will not be accurately like a natural language, but it has some qualities or some properties of the natural language like syntax. That means a structure. So there will be different symbols, and we are not using all the symbols in a single sentence. So according to the sentence, we are using symbols, we are using connectors, and we are determining which symbol is to be placed where. So this is what syntax means. The next area is the semantics. Semantic means the meaning. So how can we communicate, or how can we acquire, or how can we capture the meaning hidden in a logical sentence? Okay, that is what we call semantics. And obviously there will be merits and demerits as in every aspects. If we talk about the logical representation of knowledge, it is very much useful in the case of programming, but when we are discussing about its drawbacks, the logical representation have some restrictions, because it may not efficiently work everywhere when we are communicating, or when we are using some natural language, and it may not always be successful in representing all the natural language terms or all the natural language sentences. So we will try up to our maximum extent to represent the natural language in the form of logical sentences, and to infer knowledge, or infer some information, or do some reasoning with that. But there is some restrictions. That is a drawback. So there are mainly two different types of knowledge representation by using logic. The first one is propositional logic, and the second one is predicate logic. So propositional logic and predicate logic. The first category is the one which sometimes you may be seeing this in MOCS in the first semester. By using some propositions like true or false, some tautologies, some contradictions, the terms like that, I think it is more clear to you. In propositional logic, we are using some facts, we are using some declarative sentences. Actually, we are using some facts, and by using these facts, we are trying to communicate the messages, or we are trying to represent the knowledge. So some connectors like and, or, etc. are used here, and we are inferring whether at last the sentence is true or false. That is actually the propositional logic. See the examples of propositional logic. It is a Sunday, the sun rises from the west. Whether this is true, it's a false proposition. 3 plus 3 is equal to 7. We know it is false. Okay, 5 is a prime number. So likewise, when we see the sentence, we can at the moment when we read the sentence, it is clear whether it is true or false. That's a fact. But when we think about the propositional logic and compare that with the natural language that we are using, whether they will be same everywhere? No. In a natural language, we are not using the facts, we are using some vague communication measures. So propositional logic can handle only the facts. നോക്കൂ, ഇപ്പോൾ ഞാൻ പറയാണ് 3 + 3 = 7. ഇതുപോലെ പറഞ്ഞാൽ എനിക്കറിയാം അത് ട്രൂ ആണോ ഫോൾസ് ആണോ എന്ന്. പക്ഷെ ഞാൻ പറയാണ്, ചില ക്ലാസ്സുകളിൽ പഠിക്കുന്ന ചില കുട്ടികൾക്ക് പഠിക്കാൻ എന്തൊക്കെയോ ബുദ്ധിമുട്ടുകളുണ്ട്. ഹൗ ക്യാൻ ഐ റിപ്രസെൻറ്റ് ദാറ്റ് സെൻറ്റൻസ്? ചില ക്ലാസ്, ചില കുട്ടികൾ പഠിക്കാൻ എന്തൊക്കെയോ. സോ സം ടേംസ് ആർ ദെയർ. നമുക്ക് ഒരു ഫാക്റ്റ് എന്ന നിലയിൽ കൺവേർട്ട് ചെയ്യാൻ പറ്റാത്ത കുറച്ച് ടേമുകൾ അവിടെ വരുന്നുണ്ട്. നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജ് എപ്പോഴും ഇതുപോലെ ആയിരിക്കും. നമ്മളോട് ഒരാൾ എക്സാം എളുപ്പമാണോ എന്ന് ചോദിച്ചാൽ, വെദർ അവർ ആൻസർ വിൽ ബി ഇൻ എ ഡിക്ലറേറ്റീവ് ഫോമാറ്റ്, നമ്മുടെ ആൻസർ ഒരു ഫാക്റ്റ് എന്നുള്ള രീതിയിലായിരിക്കും വരാം. ഹൗ വാസ് ദ എക്സാം? നമ്മളെങ്ങനെയാണ് പറയുക? ഇറ്റ് വാസ് ഈസി, ഇറ്റ് വാസ് ഡിഫിക്കൽട്ട്. ഇതുപോലുള്ള 2 സെൻറ്റൻസ് ആയിരിക്കുമോ നമ്മൾ പറയാം? എളുപ്പമായിരുന്നു, പാടായിരുന്നു, ഇങ്ങനെയാണോ നമ്മൾ പറയാം? അല്ല. നമ്മളെപ്പോഴും പറയുന്നത് എന്താ? നമ്മുടെ സെൻറ്റൻസിന്, നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജിൻ്റെ ഒരു പ്രത്യേകത അതാണ്. നമ്മൾ പറയും കുഴപ്പമില്ലായിരുന്നു. ഈ കുഴപ്പമില്ലായിരുന്നു എന്നുള്ള ആൻസറിനെ നമ്മൾ ഏത് കാറ്റഗറിയിൽ പെടുത്തും? വെദർ ഇറ്റ് ഇസ് ട്രൂ ഓർ ഫോൾസ്. ബുദ്ധിമുട്ടാണ് അല്ലേ? അത് അനലൈസ് ചെയ്യാൻ ബുദ്ധിമുട്ടാണ്. സോ പ്രൊപ്പോസിഷണൽ ലോജിക് ആർട്ടിഫിഷ്യൽ ഇൻ്റലിജൻസിൽ യൂസ് ചെയ്യുന്നത് ഫാക്റ്റുകളെ റെപ്രസെൻ്റ് ചെയ്യാൻ മാത്രമാണ്. ഫാക്റ്റുകളല്ലാത്ത സെൻറ്റൻസുകളെ പ്രൊപ്പോസിഷണൽ ലോജിക് ഉപയോഗിച്ച് നമുക്ക് റെപ്രസെൻ്റ് ചെയ്യാൻ പറ്റില്ല. സോ ഇറ്റ് ഈസ് ആക്ച്വലി അപ്പം ഇതിനൊരു കമ്പാരിസൺ നിങ്ങളോട് ചോദിക്കുകയാണെങ്കിൽ you can write that propositional logic is the simplest form of logic representation where all the statements are made by some propositions or some facts. So അത് കാണുമ്പോൾ നമുക്കറിയാം ഇപ്പം sun rises from the west whether it is true or false. ഓക്കെ, സോ അത് ആ സെൻറ്റൻസ് കാണുമ്പോൾ ട്രൂ ആണോ ഫോൾസ് ആണോ എന്ന് ആ സെൻറ്റൻസിൽ നിന്ന് അനലൈസ് ചെയ്യാൻ പറ്റണം. 5 is a prime number whether it is true or false. 3 + 2 is equal to 5 whether it is true or false. It is true. So the sentence itself is a പ്രൂഫ്. പക്ഷേ നമ്മൾ ഉപയോഗിക്കുന്ന നാച്ചുറൽ ലാംഗ്വേജ് സെൻറ്റൻസുകളെ ഒരിക്കലും പ്രൊപ്പോസിഷണൽ ലോജിക് ഉപയോഗിച്ച് നമുക്ക് റെപ്രസെൻ്റ് ചെയ്യാൻ പറ്റില്ല. അതിന് പകരം നമ്മൾ ഉപയോഗിക്കുന്ന നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജുകളെ നമ്മൾ റെപ്രസെൻ്റ് ചെയ്യാൻ ഉപയോഗിക്കുന്ന ടൈപ്പ് ഓഫ് ലോജിക്കാണ് പ്രെഡിക്കേറ്റ് ലോജിക്. പ്രെഡിക്കേറ്റ്സ് എന്ന് പറഞ്ഞാൽ നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജിലുള്ള ഒരുപാട് കാര്യങ്ങളുണ്ട്. ഇപ്പം നമ്മൾ പറയുമ്പോൾ നമ്മളിപ്പം ഒരു എക്സാമ്പിൾ പറയാം. ഇപ്പം നമ്മുടെ ഗ്രൂപ്പ് അഡ്വൈസറുടെ അടുത്ത് നിന്നിട്ട് നമ്മളൊരു സജഷൻ പറയുകയാണ്. നമ്മുടെ ക്ലാസ്സിൽ എന്തെങ്കിലും ഒരു ഫീച്ചർ വേണം. ഇപ്പോൾ സപ്പോസ് നിങ്ങളുടെ ക്ലാസ്സിൽ പ്രൊജക്ടർ വർക്ക് ചെയ്യുന്നില്ല, അല്ലെങ്കിൽ നിങ്ങളുടെ ക്ലാസ്സിൽ സീറ്റിംഗ് അറേഞ്ച്മെൻറ്റ് കറക്റ്റ് അല്ല, പ്രോപ്പർ അല്ല, നിങ്ങൾക്ക് കാണാൻ പറ്റുന്നില്ല. നമ്മൾ എങ്ങനെയായിരിക്കും ആ മെസ്സേജ് എന്ന് നമ്മുടെ ഗ്രൂപ്പ് അഡ്വൈസറുടെ അടുത്ത് പറയാം? മാം, ഇപ്പം ഇങ്ങനൊരു പ്രശ്നമുണ്ട്, അപ്പോൾ ഞങ്ങൾക്ക് കാണാൻ പറ്റുന്നില്ല. അപ്പോൾ ചോദിക്കുക, എന്താ പ്രശ്നം, ആർക്കാണ് പ്രോബ്ലം? ഇല്ല, മിക്ക കുട്ടികൾക്കും. അങ്ങനെയാണ് നമ്മൾ പറയാം. ഇന്ന കുട്ടി എന്ന് നമ്മൾ ഫോക്കസ് ചെയ്യുമോ? ഇല്ല. ഏത് നാച്ചുറൽ ലാംഗ്വേജ് സെൻറ്റൻസ് എടുത്താലും നമ്മൾ കമ്മ്യൂണിക്കേറ്റ് ചെയ്യുമ്പോൾ നമ്മുടെ കമ്മ്യൂണിക്കേഷൻ എപ്പോഴും ഫാക്റ്റുകളിലല്ല പ്രപ്പോസിഷൻസിലാണ് നിൽക്കുക. ചില കുട്ടികൾ, കുറച്ച് പേര്, അങ്ങനെയാണ് നമ്മൾ പറയാം. ക്ലാസ്സിൽ ചിലർ, ക്ലാസ്സിൽ കുറച്ച് പേര്, മിക്ക കുട്ടികളും. അവിടെ ഒരു ഫാക്റ്റില്ല. ആ മിക്ക കുട്ടികളും എന്നുള്ള കാറ്റഗറിയിൽ ആര് വേണമെങ്കിലും വരാം. ഓക്കെ, സോ അങ്ങനെയുള്ള വേഗായിട്ടുള്ള റെപ്രസെൻറ്റേഷൻസിന് വേണ്ടി യൂസ് ചെയ്യുന്ന ഒരു കൺസെപ്റ്റാണ് പ്രെഡിക്കേറ്റ് ലോജിക്. നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജ് സെൻറ്റൻസുകളെ പ്രെഡിക്കേറ്റ് ലോജിക് ഉപയോഗിച്ച് നമുക്ക് റെപ്രസെൻറ്റ് ചെയ്യാം. അതെങ്ങനെയാണ് റെപ്രസെൻറ്റ് ചെയ്യുന്നതെന്ന് നമ്മൾ കാണും. ഓക്കെ, സോ ഇൻ പ്രൊപ്പോസിഷണൽ ലോജിക്, ഇത് പറയുന്നത് പ്രൊപ്പോസിഷണൽ ലോജിക്കിൻ്റെ ഡ്രോബാക്സ് ആണ്. അത് സോൾവ് ചെയ്യാനാണ് പ്രെഡിക്കേറ്റ് ലോജിക് ഉപയോഗിക്കുന്നതെന്നാണ് പറയുന്നത്. ഓക്കെ, ഇൻ പ്രൊപ്പോസിഷണൽ ലോജിക് വി ക്യാൻ ഓൺലി റെപ്രസെൻറ്റ് ദ ഫാക്ട്സ് which are either true or false, but in the natural language sentences it is not possible by using that, because even ഒരു എക്സാം എങ്ങനെ ഉണ്ടായിരുന്നു എന്ന് ചോദിച്ചാൽ പോലും ട്രൂ അല്ലെങ്കിൽ ഫോൾസ് ആണ് എന്ന് കൺവേ ചെയ്യുന്ന ഒരു മെസ്സേജ് അല്ല നമ്മൾ കൊടുക്കുന്നത്, അല്ലേ? സോ ഇൻ പ്രൊപ്പോസിഷണൽ ലോജിക് ഇറ്റ് ഇസ് നോട്ട് സഫിഷ്യൻറ്റ് ടു റെപ്രസെൻറ്റ് ദ കോംപ്ലെക്സ് സെൻറ്റൻസസ് ഓർ ദ നാച്ചുറൽ ലാംഗ്വേജ് സ്റ്റേറ്റ്മെൻറ്റ്സ്. So the propositional logic has very limited expressive power, and because of that we are moving on to predicate logic to represent the knowledge or the sentences like some humans are intelligent. Chella manushyara intelligent aanu. Sachin likes cricket. Okay, so likewise Sachin likes cricket എന്ന് പറയുന്ന ഒരു സെൻറ്റൻസ് ആണ്. പക്ഷേ അതൊരു ഫാക്റ്റ് ആണെന്ന് നമുക്ക് പറയാൻ പറ്റും. എത്ര സച്ചിൻ ഉണ്ടാവും? ഓക്കെ, സോ ഇതുപോലുള്ള നമ്മുടെ നാച്ചുറൽ ലാംഗ്വേജിലുള്ള സെൻറ്റൻസുകളെ സിമ്പിളായിട്ട് റെപ്രസെൻറ്റ് ചെയ്യാൻ നമ്മൾ ഉപയോഗിക്കുന്നത് പ്രെഡിക്കേറ്റ് ലോജിക്കാണ്. ഓക്കെ, സോ ടു റെപ്രസെൻറ്റ് ദി അബവ് സ്റ്റേറ്റ്മെൻറ്റ്സ് വി റിക്വയർ സം മോർ പവർഫുൾ ലോജിക്, ആൻഡ് ദാറ്റ് പവർഫുൾ category of logic representation is called the predicate logic. Okay, so hope you have got an idea about knowledge representation using logic now. So this is an introduction. Okay, what is the relevance of knowledge representation, and what are the different types of knowledge involved in that, what are the different types of knowledge representation using logic, and what are the drawbacks in that, and which is the best in that. Okay, ഇതുപോലുള്ള കാര്യങ്ങളൊക്കെയാണ് നമ്മളിവിടെ പറഞ്ഞു പോയത്. ഇറ്റ്സ് ജസ്റ്റ് an introduction. I hope നിങ്ങൾക്കത് മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു. ഓക്കെ, താങ്ക് യു.